Hello and welcome to this video, which is an introduction to matrices. So our first question is, what is a matrix? A matrix is a rectangular array of elements set out in a pair of brackets. And here you can see one with 2 rows and 3 columns, and the elements are 1, 2, 3, 4, 5, 6. In this video, we will be looking at how to add, subtract and multiply matrices, as well as how to find the inverse of a matrix. And to do that, we need to understand size rules. So a matrix is defined by the number of rows and the number of columns in that order. So the number of rows times the number of columns. In our example, 1, 2, 3, 4, 5, 6, it has 2 rows and 3 columns, so it's a 2 by 3 matrix. And two matrices can only be added or subtracted if they have exactly the same number of rows and exactly the same number of columns. So let's just have a look at some examples. So could we, for example, add or subtract A and G? Well, A is a 2 by 3 matrix, G is a 3 by 3 matrix, so no, we couldn't. B and F, on the other hand, are both 2 by 2 matrices, so they are the same, so they can be added or subtracted. J is a 2 by 3 matrix and D is a 3 by 2 matrix, so no, they cannot be added together. D and E are both 3 by 2 matrices, so they can be added. G can of course be added to itself because it is exactly the same size as itself, and then A and J are both 2 by 3 matrices, so yes, they can also be added or subtracted. So on the handout, we've been asked to add the matrices A and B and to subtract B from A. So to add two matrices together, we simply add the corresponding elements in each matrix. So the matrix A is given by 3, 5, 4, negative 2. The matrix B is given by negative 1, 6, negative 3, 4. So to find the top left element, we do 3 plus negative 1, which is 2. For the top right, 5 plus 6 is 11, and so on. And the order doesn't matter. A plus B will of course be the same as B plus A, like it is with normal addition. For A take away B, we simply subtract the corresponding elements in each matrix. So this time we would be doing 3 take away negative 1, which is 4, and 5 take away 6, which is negative 1, and so on. And of course, with subtraction, the order does matter. The rules for multiplying matrices is a little more complicated. So let's have a look at it. Imagine we have two matrices P and Q, where P is designated R1, C1, and Q is designated R2, C2. PQ, the product of P and Q, can only be evaluated if C1, the number of columns in matrix P, is equal to R2, the number of rows in matrix Q. And the answer will be in the form R1C2, so we'll have the number of rows of matrix P and the number of columns of matrix Q. So let's look at these matrices again and see if we can multiply them. So AG, for example. A has 2 rows and 3 columns, as indicated by the first blue line, and G has 3 rows and 3 columns, as indicated by the second blue line. In the brackets, that's the number of columns of A, which is 3, and the number of rows of G, which is 3. They're the same, so they can be multiplied, and the answer is a 2 by 3 matrix, which are the numbers on each end. BF, B is a 2 by 2 matrix, so it has 2 columns. F is a 2 by 2 matrix, so it has 2 rows. The number of columns of B and the number of rows of F are the same, and the answer is a 2 by 2 matrix. For JD, J has 3 columns and D has 3 rows, so they can be multiplied, and the answer is a 2 by 2 matrix. DE cannot be evaluated, however. D has 2 columns, E has 3 rows, they are not compatible. G times itself is possible because G is what is called a square matrix, so it has the same number of rows and columns, and the answer will also be a 3 by 3 matrix, since G itself is a 3 by 3 matrix. And then finally GA, notice that AG was possible, but GA is not. G has 3 columns, A has 2 rows, and hence they cannot be multiplied. So multiplication is not commutative. So let's look at how to actually multiply matrices. And as it says, we multiply and add the elements in corresponding rows and columns. So for the matrix A times the matrix B, we start by looking at row 1 of matrix A and column 1 of matrix B, and we times the 3 by the negative 1 and the 5 by the negative 3, and then we add those together, and that gives us negative 18. And then we do something exactly the same for each other row and column. So for row 2 in A and column 2 in B, we do 4 times 6 plus negative 2 times 4, which is 16. When we work out BA, so in BA I've illustrated row 1 of A times column 2 of B. We're doing negative 1 times 5 plus 6 times negative 2, which is negative 17. Do the same for all the other pairs of rows and columns, and notice that the answer is not the same as AB, again confirming that multiplication is not commutative. The order does matter. And then A squared, timesing A by itself, I've done A row 2 and A column 1. So that's 4 times 3 plus negative 2 times 4, and the answer for that is 4. Now we're going to look at how to find the inverse of a 2 by 2 matrix. And the first thing we need to do is to evaluate what is called the determinant, which is given by AD minus BC for the matrix ABCD. And in the inverse matrix, M minus 1, is given by 1 divided by the determinant multiplied by D minus B minus CA. So D and A, which are called the elements on the leading diagonal, have swapped around, and B and C have changed signs. So what does an inverse do? Well, a matrix M multiplied by its inverse gives what we call the identity matrix, which is the equivalent of the number 1 in normal numbers. And you may remember from earlier when we had a matrices A to J, the I was given by 1, 0, 0, 1. So in 2 by 2 matrices, this is the identity matrix. And M times M minus 1 and M minus 1 times M will both give us I, the identity matrix. So in this respect, multiplying by the inverse is equivalent to dividing. However, you can only find the inverse of a matrix if the matrix is a square matrix, i.e. 2 by 2 or 3 by 3, for example, and if it's non-singular, which means that the determinant is not equal to 0. So back with our 10 matrices, pause the video and see if you can work out which ones definitely have inverses, which definitely do not have inverses, and which ones you're currently unsure about because I haven't given you enough information. B and I definitely have inverses. They're both square matrices with a non-zero determinant. The determinant of B is 8 and the determinant of I is 1. A, C, D, E, H and J definitely do not have inverses since they're not square matrices. And although F is a square matrix, the determinant of F is 0, so it also does not have an inverse. And unless you've learnt this already, you should be currently unsure about G, because although it's a square matrix, we don't yet know how to find the determinant of a 3 by 3. So now we're going to show how an inverse matrix can be used to solve simultaneous equations. So here is a pair of simultaneous equations, 3x plus 5y equals 5 and 4x minus 2y equals 37. And that can be rewritten with matrices as 3, 5, 4 minus 2, xy, a 2 by 1 matrix, and 537, the answers. And if you imagine multiplying 3, 5, 4 minus 2 by xy, you would do 3 times x plus 5 times y, and that would equal 5, and 4 times x plus negative 2 times y, and that would equal 37. So the simultaneous equations are equivalent to our matrix multiplication. Now, of course, we could solve these simultaneous equations in the traditional way, but we can then use this method for 3 by 3 matrices, which makes life a lot easier. So, given 3, 5, 4 minus 2 times xy is 537, xy can be found by multiplying the inverse matrix by 537. So let's start off by finding the inverse matrix. Top left, the determinant of A is 3 times minus 2 minus 5 times 4, which is negative 26. And then we've changed the elements around on the leading diagonal. So the minus 2 is top left, the 3 is bottom right, and we've changed the signs of the 5 and the 4. So the inverse matrix is given by negative 1 over 26 multiplied by negative 2, negative 5, and negative 4, 3. Then if we times that by 537 in the rectangle at the bottom, we end up with answers of 7.5 and minus 3.5, and you can check them in the traditional way to see if they are correct. You can use your calculator to find inverse matrices, so you could pause the video here for the FX991EX, and this is how you would do it on the FX991CW. Here are some practice questions for you, including adding, multiplying, finding the inverse and solving simultaneous equations. And here are 4 slides of answers. Here are the inverse matrices for M and K. Here's the solution for part A of the simultaneous equations. And here is the solution for part B of the simultaneous equations. Thank you for listening.